Hello friends, myself Professor Shubhangi Ingre from the TSSM Bhurabai Savan College of Engineering, Research, Narepuni, Department of Computer Engineering. Now in today's sessions, I am going to teach you the laboratory practice 1. Now I am moving to the next slide, that is assignment number 1 of the data analytics. The title is the IRIS datasets analysis in RStudio to perform the with the help of R programming. Now I am read the statement. Download the IRIS flower datasets or any other datasets into the data frame. This will be available in that CSV file will be available from this website. Use the Python or R programming and perform the following. The first operation, some 4 operations are given in front of you. So first operation is the how many features are there and what are their types. Example, a numeric and the nominal. Second operation, compute and display the summary statics for each features available in the datasets. For example, we have to implement the minimum value, maximum value, mean, range, standard deviation, variance and percentile. Third one is nothing but the data visualizations. Create a histogram for each features in the datasets to illustrate the feature distributions and plot each histogram. Fourth one, create a box plot for each features in the datasets. All of the box plot should be combined into the single plot and compare the distributions and identify the outliers. This is about the problem statement of the data analytic assignment 1. Now, learning objective of this assignment. First, to learn how many features and types available in the datasets. Second objective, to learn how to display the summary statics for each features available in the datasets. Third one, to learn the histogram for each features in the datasets. Fourth one, we need to plot all the box plot for the features in the datasets. Now outcome, student will able to understand the features and their types that is available in the datasets. Students will able to understand the summary statics. In that we are finding the minimum value, maximum value, mean, range, standard deviation, variance and percentile. Student will able to understand how to implement a histogram for each features in the datasets. Fourth one, student will able to understand how to plot box plot with the 4 features. Now I am turning to the theory concept. First operation is nothing but the how many features are there and what are their types. Numeric, example is given in numeric and nominal. First, we have to understand what is given in the IRIS datasets, IRIS flower datasets. This datasets consists of 150 samples, and in that 150 samples we are having 5 attributes: sepal length, sepal width, petal length, and petal width, and spices. In that we are having the spices. We are having the 3 classes: Iris centosa, Iris virgina, and Iris versicolor. In that, the 4 features are measured from each sample. The length and width of the sepal and petal length are in the centimeters. Okay, this is for the IRIS flower datasets. Now we are moving to the first operation, that is for the how many features are there and what are their types. First is data types. Data types are the important concepts of the statistical which we need to understand to correctly apply the statistical measurement to your data and therefore to correctly conclude the certain assumptions about it. Now data type having the 2 parts, that is a categorical and numerical, and in the categorical we are having the nominal and ordinal, and in the numerical we are having the interval and the ratio. Now first moving to the categorical. Categorical represent the characteristics. Therefore, it can represent things like person, gender, language, etc. Categorical data can also take the numeric value. For example, 1 for female and 0 for the male. But note that there is a no does not have the mathematical meaning. Then second one is the nominal data. first one, nominal data. In that nominal data, this represent the discrete unit and are used to label the variables that have no quantitative value. Note that the nominal data has no order. Therefore, if you will change the order of its value, the meaning will not change. That is about the nominal data. Then we are moving to next one is the ordinal data. The ordinal value represent the discrete and order units. For example, what is your education background? This is the question. In that you are having the 4 option. First option is the elementary, second option is the high school, third option is undergraduate, and fourth option is the graduate. But note that the difference between the elementary and high school is different than difference between the high school and the college. This is the main limitation of ordinal data. The differentiate between the value is not really known. Because of that, the ordinal states are usually used in the measure of non-numeric features like happiness, customer satisfactions, and so on. Now we are moving to the numerical data. In the numerical data, we are having the interval data and the ratio data. Numerical data, in the numerical data, we are having the interval data. That interval value represent the order unit that have the same difference. Therefore, we speak in the interval data when we have the variance that contains a numeric value that are order and where we know the exact difference between the value. For example, the temperature is given -10, -5, 0, +5 and +10. This is for the interval data. Now for the ratio data, the ratio values are also order unit that have the same difference. The ratio value are the same as the interval value with the difference that they do not have the absolute 0. Example, height, weight, length, etc. This is for the nominal numerical data. Now we are moving to our second operation, compute and display the summary statistics for the each features available in the data sets. First we have to calculate the minimum value. The function is given in front of you for the R programming. Print s apply df function x minimum as numeric x. Df is nothing but d variable type is here, that is the data frames, and with the help of this function we get the output from the iris flower data sets. The sepal length is given 4.3, sepal width is given 2.0, petal length is given 1.0, petal width is 0.1, and spices is 1. This is from the data whatever we get it from the CSV file. From that, once you write this statement in the R statement, you will get the answer. Now in the maximum value, maximum values, this is the print s apply, same as the minimum value. We are calculating with the help of the max only. Again we get the maximum value from the table whichever available in the CSV file. With the help of next is nothing but the mean function. In the mean function, we are having this mean function. With the help of this function, we get this kind of the output. Then range. Range function is actually as an object containing the minimum and maximum in that orders, or the range can be easily computed by subtracting the minimum from the maximum. With the help of this one, we'll get the range. So we get the minimum range and we get the maximum range, as it is subtractions from the given in the equation, given in the range, subtract the maximum minus minimum, so you get the range. So 4.3 that is already given in the previous slide, and 7.9 that is given in the previous slide of the maximum. Next is nothing but the standard deviation. Standard deviation are computed if the data represent a sample, so that the denominators is n-1, where n is the number of the observation. So with the help of this SD function we will get the output. Then variance. Variance, the coefficient of the variation is the standard deviation divided by the mean. So with the help of this function, we'll get the variance. Then our third operation is nothing but the data visualization. In the data visualizations, create a histogram for each features in the data sets to illustrate the feature distribution and plot each histogram. Some images given in front of you, we have to implement the histogram. We have to implement the histogram for the sepal length, petal length, sepal width and petal width. This is with the help of the feature distributions. We are having the four features, that is the sepal length, sepal width, petal length and petal width. Now we are moving to the data visualization. The data visualization have the two terms. First is the data, that is nothing but the information, and visualization is nothing but the pictorial representation or graphical representations of the information, so that the user can easily analyze the data quickly. So in the feature distributions, we are having the four features that is given in the table, the CSV file. So we are having the sepal length, sepal width, petal length and petal width. Based on that, we implement the histogram. What is the histogram? Histogram gives an idea about the distributions of the quantitative variables. The idea is to break the range of the value in the intervals and count how many observations fall into the each interval. Histograms are used for the quantitative variables, that is the hist. This is the output. Now create a box plot. For the box plot, create a box plot for each features in the data sets. All of the box plots should be combined into the single plot. Compare the distribution and identifying the outlier. We are having one diagram in front of you. One boxes are there. That box plot is nothing but the graphical summary of the distribution. The box is in the middle line indicate known as the hinges, that is closer to the first and third quartile and the medium. And this line shows the largest and smallest observation that fall within a distance distance of the times the box size from the nearest hinges. A box plot can give a good idea of the data distribution and is more useful to compare the distribution side by side, as it is more compact than the histogram. Okay, this is for the fourth operation. Okay, thank you. Thanks for watching. Hello friends, now we are starting the practical executions of the data analytic assignments, that is download the IRIS Flower datasets or any other datasets into the data frame using the RStudio and with the R programming languages. Okay, now I'll start with our execution. We are moving to the R script. Here we get the R script. Now I start the writing the assignment for the practical executions of the analytics, data analytics. iris.csv. Here I am given df is nothing but the variable of the data frames. I am implementing the functions as a read.csv. In that here df is the data frames which will store the data in the tabular format. So now we move to the next function, that is the print summary and the structure. So it will be implement our first operation. See the summaries of the data sets. So we'll get the summary. Summary of the data frames. Now we are moving to our next operation, that is the in the second operation we have to find out the summary statistics. In that we have to find out the minimum value, maximum value, average value, range of the value, standard deviation and the variances. So we'll start the writing for this one. Minimum value, print. Apply df. Sorry. Function of x minimum as numeric x. With the help of this function we get the minimum value from the CSV from the CSV files. Print maximum value again we apply the same functions, so I am copying this equation. Print s apply df functions x maximum as numeric of x. Now we are moving to the next function is our apply finding the mean or average value. So print the average value. Now after average value we are calculating the range of value. After the range of value, we are calculating the standard deviation. Now the standard deviation. print for the variances. Now for the percentile, again I am explaining the here what we are finding the minimum value. Here minimum value takes the minimum value from the data frames and store as a numeric value in the x variable. Each and every time, and here is the x is a variable, and it store the numeric value in the x variable. Okay, this is for the second operation. Now I am moving to the third operation. Here I am writing the num is equal to the C 1, 2, 3, 4. In that cases, that C is nothing but D. There are 4 features available in the Iris datasets. That is sepal length, sepal width, petal length, petal width. So that is the CSV column. For n in num. Here num is a variable, and so we are taking the 4 column operation, so we can perform the 4 operation at the same time. Column category column n double quotes \n. Here is the cat is nothing but D. It is an inbuilt Also the RStudio, it build the character to print the screen. Print quantile df open bracket comma n probability props. Here we get the props is the numeric vectors of the probability with the values in 0 and 1. 0, 2.5, 0.5, 0.75 and 1. This code is for the third operation. Now we are moving to the fourth operation. For n in num, again we are taking the n in num. In that we have to implement the histogram. In this histogram, we are giving the sleep time for implementation of the all 4 features that is given in the CSV file. Now we are box plot. One is to 4, comma main box plot of iris. Now our in the script we done the program. Now I'll save this program iris.r. iris.r execution of the program. Now run this program. For run this program, Control A, copy this program, before that we import the database. That is the IRIS CSV file. Import that file. Here we are importing the CSV file. So we get the 4 features, that is the sepal length, sepal width, petal length, petal width and species. So we get the total objective total 150 and there is a 5 variables. So you will get the view.iris. So after that you select all, Control C and paste here and enter. So you get the output. Here you get the output. Our first operation, we need the summary and structures for the this one. So it will be print summary. Now after that we require the minimum value from that given tables, that is the IDs. In that we get the minimum value, we are having the maximum value, we are needed the average value, that is nothing but the mean value, and after that we need the range, then standard deviation and variances and percentile. And according to that it will be a plot the box plot. Here is the box plot. You get the box plot of the IRIS. It will be implement the separate box plot, sepal length, sepal width, petal length and the petal width for the 4 features. So this is the practical executions of the LP1 assignment. Thank you for watching.